Hello guys, welcome back to another video. I'm Haroun and we're gonna be doing chapter 1, 1.2, 1.3, 1.4 for science periodic that is due after tomorrow. If you have any questions, if I didn't explain anything, please leave a comment and I'll answer it. We'll start off. I'll be giving you notes through on. If you want to screenshot, yes, you can screenshot. Please screenshot us on if it's better for you. Okay. Magnesium atom has 12 electrons. Okay. They told us 12. Now before we go through this, we need to learn something. You need to remember this set of numbers, okay? This is the set of let's say valence electrons set. I'm not sure what you want to call it. But they told us 12 electrons, okay? You want to be able to fill up all of these. Every single one of these, you want to fill it up. So you can fill up 2, you'll be left with 10. You can fill up 8, you'll be left with 2. Okay? Now, how? It's hard to explain. But you have 12, you need to fill up the numbers. So 12 minus 2, since you can fill up 2, you'll be left with 10, right? From 12. And then you can do 10 minus 8. You'll be left with 2. So then you fill up the last box with the last number you have. And the last number is the number of valence electrons you have. Is the valence electron of that element. So the magnesium atom, its set of valence electrons is 2, 8, 2. And the valence electron of that atom is 2. The last one. Okay? So it's 2, 8, 2. We explained it. It's found in the last. And since, the original is 2, 8, 8, 16. 12 electrons doesn't have enough to fill up everything. It only has enough to fill up 3. And not fully. Okay? If you want to find the valence electrons, it's in the last one. So it's found in the third one of this, in this case, because there's 3 only. Now, if you want to find the similar chemical properties, you look at the number of valence electrons, and then you see which one is similar. 1 and 6 and 1 and 2. 1 and 1 are similar, so it's A and C. But this is only for the number of valence electrons, not for this. Don't think it's A and B. Okay, for this one, octet rule. So the octet rule, I'm gonna explain it very quickly and very forward. I don't know what you call it. 0, 8. 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay, why did I do this? I want to show you something. 0, 1, 2, 3, 4 is how about I'll explain this when you get to that question. I just need to read it. The number of energy level. This is gonna be hard to explain. What is an energy level? Energy level is, let's say this one has an energy level of 1. Okay? Wait. I need to find a good explanation. Okay. Copilot help me. Energy level is we're gonna use this again, 2, 8, 8, 16. This is 1 energy level, this is 2 energy level, this is 3 energy level, this is 4 energy level. You want something that's 8 or above. 1 is 2. It's not above. The first energy level is only 2. It's not 8 or above. The second one is 8, so this is correct. And the third one is 8, so this is correct. And the third one is above 8, so this is correct. All of these follow the octet rule. Okay? So this one has 3, and this one has 4. As we said here, I'm gonna show. Again. 2, 8, 8, 16. This is the third one. This is the third one. Don't mind this. This is the third one, this is the fourth one. These are both 8 and above, so it's B and C. If you don't understand, just leave a comment. I'll explain it. Try my best to explain it better. Okay. Why does a sodium ion have a charge of 1 plus? Okay. This is where we explain the octet rule. Or not this one. Why does it have 1 plus? Because it has 1 proton more. Because it's 1 plus. This is where. 0, 1, 2, 3, 4, 5. Okay. You're asking you for the number of valence electrons. This one has a number of 1 valence electron. This is where we use this. It has 1. See, anything under 4, like let's say you want it to be 0 or 8. صح? Because 0 is stable and 8, let's say it's also stable. You don't want anything in between. If you have 1, you won't want to make it 8. Like you don't want to do make it to 8. The closest thing you can make it is to 0. So like anything under 4. So if it's 4, you want to make it into 0. If it's 3, you want to make it into 0. If it's 2, you want to make it into 0 and so on. But if it's 5, you want to make it into 8. And if it's 6, you want to also make it into 8. And 7, you want to make it into 8. You understand? This one goes to 0. These go to 8. How do you turn it into 0? Since you have 1 valence electron and you want it to be 0, you need to take 1 electron away, because you're not talking about protons, you're talking about electrons. If you want to take 1 electron away, you can't remove. Can you remove electrons? No, you can't. Electrons are added and removed, right? Anyways, if you want a similar amount of electrons, you need to add 1 proton, I think. Yeah, it needs to be plus 1. Because if it's minus 1, this will become 2. Because we're talking about electrons here. If you add an electron, it's going to be 2. Because electron. So plus 1. This one, it's 6. It's above 4. So you want it to be 8. What do you do? Minus 2. We're talking about electrons here, not plus 2. Because if you do plus 2, it will be 4. It will go down. If you do minus 2, it will become 8. Because these 0, 1, 2, 3, 4, 5, 6, 7, 8, these are electrons, not protons. Okay? So think of it as, this is a good way to put it. 0 to 4 is addition. 5 to 8 is subtraction. See, this is subtraction. So it's minus 1 because you want it to be 8, and plus 7 plus 1 is 8. Is it minus 1? I feel like I'm messing up. Anyways, 3 plus 3, because anything 0 to 4 is plus. Okay? Hopefully I explained it in a way that you guys can understand. This one, what do we do? 2, 8, 8, 16. If you guys didn't understand, then focus here. 16, you want to replace it with all of these. Okay, 16, you have enough to replace it for 2. You have 14 left. And you have enough to replace it for 8. You have 2, 14. Oh yeah, you have 6 left. And you don't have enough to make this full, but you just place it there. What you have left, you place it there. And this is your valence, the number of valence electrons, because what you said the last is the number of the valence electrons, okay? So the first one, energy level 2. Second one, 8. Third one, 6. Now here's you're asking you, sulfur has how much valence electrons? 6. We said the last one. And the ion formed by sulfur. Now for this one, what's the ion formed by sulfur? You take the valence electron, and since it's above 4, like 5, 6, 7, 8, you want it to be minus. صح? That's what we said. If you guys go back, take a screenshot of it and memorize. So it's gonna be minus 2, because 6 plus 2, think of this as plus. I don't want you guys to get confused. 6 minus 2 is 8. Okay. Two minus. Let's go on to the next quiz. Let's just see if we got all correct. Okay, next quiz. Okay, guys, this is a long quiz. I was doing it. Let me just save and exit, and I'll put in the new one. And by the way, why was I doing it? I restarted the whole quiz because I was like paused the whole time. The whole time I was paused. Wait, let me see. Start new quiz. Okay, guys, I'm gonna do something here which will help you, okay? This vertical is a group. This horizontal is a period. Now, a group is also called a column. How do you spell it? I don't know. Don't make fun of me. Wait, let me see how to spell it. Okay, am I recording? Okay. Don't mind that. Okay. Where was I? Yeah. And this is a row. Now these, in chemistry, these are called groups and periods. And I want you guys to screenshot this. Now, a group, elements in a group have similar properties. Like they might say chemical properties, same thing. And for the periods, elements in a period, which is the row, have the same number of energy levels. Okay, I want you to screenshot this. I can't see anything. Please screenshot this quickly, because I'm gonna be using it in the whole quiz and I won't go back. Okay. No. They want what's false. P and Cl are in the same period. If you understand this question, you're gonna be like, you're gonna have like, it's gonna be easy for you to solve this whole quiz. P and Cl. P and Cl. We said period is the horizontal. Are they in the same horizontal period? Yes, they are. So this is true. O and S, same number of valence electrons. Oh, and also, I forgot to say something. Wait, where did I go? Yeah, for this and the same number of valence electrons. Okay, take a screenshot. This is correct because O and S are in the same group, the vertical one. Okay, same group. AR atom has one more than Cl atom. Now, there's something I'm gonna tell you. You see these groups? Okay. The ones in group 18 have 18 electrons. The ones in group 17 have 17 electrons. The ones in group 16 have 16 electrons. And the ones in group 15 have 15 electrons. And that's also how it is for the groups below. Okay? Since you know that now, 18, AR has 18 electrons and Cl has 17 electrons. Does AR have one more than Cl? Yes. So this is true. Br and Se are in the same period. The Br and Se have similar chemical properties. We'll go back on that. Ar and Ne have similar chemical properties. We said that in the same group. If they are in the same group, they have similar chemical properties. That is true. This is not true because Br and Se are in the same period. And we said for same period, they have the same energy levels, not the same chemical properties. Why is that there? Chemical properties. That's why this is false. Okay, metals. So people like in grade 3 can answer this, okay? Metals, they do conduct electricity. They can't bend, okay? They can become many shapes, like they can become like fences and those things. So these two are obviously out of the list. They conduct heat well. Yes, they do. That's how they change their shape most of the time. They are malleable. What does malleable mean? Malleable means it can change its shape. So let's see, like, we have this metal. It can become a coil. It can become a metal paper that's bendy. It can become all of that. So are they malleable? Yes. Most metals are liquid at room temperature. I think the only metal that's liquid at room temperature is mercury. And mercury is like, search it up. This is not true. Non-metals. Is that not? Yeah, okay. Non-metals are magnetic. No, they are not. Non-metals are not magnetic. Are they malleable? No, they are not. They're asking for what's true. This is not true. This is not true. They can break easily. Yes. Are they dull? Yes. What does that mean? That they're very, like, they can break easily. It's same thing. It's just, I'm not sure. What does that mean? Okay. It means like I think it's not strong. That's what it means. Is it? So this is something else. Located on the right of the periodic table. This is right. Let me tell you why. All metals are located in the middle and to the left of the periodic table, while the non-metals are located on the right. Okay? So, metal... Did I spell metal wrong? No way. I didn't. Calm down, calm down. Located on middle and right. Non-metals located right. 1 second, let me just change this because it's wrong. Middle and left. Excuse me. Non-metals, bring this down, are located on the right of the periodic table. Okay? Go back and screenshot, please. If you want, of course. Now for this one, metalloids. Metalloids are... Pause the whole time. Okay. Same thing happened then. Guys, non-metals they are dull, they break easy, they're located on the right of the periodic table. They conduct heat well. This is about metal. Metal is easy. Okay, let's talk about this. Metalloids on the periodic table. Ya Rabbi. Just look at this. They are on the right of the periodic table and they form a zigzag pattern. Memorize this, that they form a zigzag pattern because it will come in the exam most probably. So they form a zigzag pattern. Okay? Now about metalloids. Okay. Are they brittle? Yes. They may be shiny and they can conduct... Okay, so listen here. Metalloids, they can conduct electricity but only under certain conditions, okay? Like certain conditions have to be met before they can conduct electricity. They cannot bend because why? They are brittle. And they are located on the left. This is false because since like what I said like 2 minutes ago, metals are found on the left, not metalloids. Okay, like we said, atomic number. I don't know if I explained it. Atomic number. Number of protons, okay? Atomic number is equal to the number of protons found in the nucleus. Found in the nucleus. Take a picture, please, if you want. Okay. Each row in the... I have to do this because I can't see my monitor. Each row in the periodic table, blank and blank. I'm not going to explain what like I already did. Elements that have the same number of valence electrons in the column, blank. We already explained this, and since this is the last answer, it goes here. You have to memorize this because we didn't take it yet. The atomic number, which the protons increase by 1 for atoms across the period, which is the one that's horizontal. Across a period, we said it's an atomic number. And down a group, number of valence electrons. Is that actually... yeah, okay. We already said similar properties, it's in the group. And in the group, why are elements in the same group? It's either because they have the similar properties or valence electrons. So it's sodium and potassium. This one. Fluorine and chlorine. They're in the same group. And since they are in the same group, they have similar chemical properties. Okay, for this one. Most atomic mass will be found in decimal. The element symbol is O. The element name is oxygen, and the atomic number will be found on the top. Okay? Period and group has nothing to do with this, so you shouldn't even choose them at all. An element that can conduct heat and electricity is obviously a metal. An element that does not conduct electricity and is dull is called a non-metal, and can conduct electricity under certain conditions is metalloid. We already explained this. Silicon, under certain conditions, metalloid. We already explained this as well. Copper is a metal. Everybody should know this. It's one of the most best conductors of electricity. Upper right corner, we said on the upper right is the non-metal. And like down is this question. Mendeleev is this guy that found a element called germanium. This is just remember. I just went on Copilot and I asked. It can represent pattern of the elements. Okay, just memorize it. Rubidium, which is Rb here, has 1 valence electron because we said in the same group has like, see, this is 1, right? And it's all in one group. Every single element here has 1 valence electron. Every single element here has 2. Every single element here has 3. Every single element here has 4. So calcium has 2. You see, calcium is here. It gives you the symbol. This is called the symbol, not the name. What is the name of the table No way you guys are asking this. Okay. Where are metals found? To the left side, in the middle. Where are metalloids found? On the right side. We explained this already. Ya Rab, I got all correct. Ya Rab, Ya Rab, Ya Rab. Please, 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 please. Ya Rab. What? Allah. It is on the right side. Okay. أنا حمار. Along the red zigzag line. It's still on the right side, but they want us to be specific. I'm gonna count that as right. I don't care. Ya Rab, the last quiz has little questions. Okay, guys. 15 questions. Is that transitive? Transition metals. Okay. Transition metals are metals that are found. This is one thing to know. Group 3 to 12. They are found in groups 3 to 12. Not every single element from group 3 to 12 is transition, but they are found there. They are silvery gray. This is not. Most of them I would say are silvery gray, but not all of them. This is why this is not true. Like copper, let's say copper is an example. Like copper is, I think, like reddish, something like that. They are shiny, yes they are, and they can be used as catalysts. See, transition metals is transition. Yeah, they can be used as catalysts. Okay, memorize that, please. Lanthidines and actinides. What are those? I forgot them. 1 second. Okay, guys, while I was using Copilot, I just wrote down some notes for you for this. Lanthanides are located in the 6th. And actinides are located in the 7th. Since they are located in the 6th and 7th, they do have a place in the periodic table, so this is wrong. All actinides are radioactive. I have a way of memorizing this, but I'm not going to share it with you because it's a stupid way. And lanthanides are shiny. They are not found in groups 14th and 15th because they are found in groups 6th and 7th. Please screenshot it if you want. Okay, noble gases. Noble gases are found in group 18. صح؟ Okay. I knew they were in group 18, and I knew they were not very dense, but I didn't know about these. They have a full set of valence electrons. Okay, this is true. They do have a full set of valence electrons, and since they do, this means that they are inert. What does inert mean? Inert is basically that they do not react with other elements because of their electron shell. Chemists often replace the air container with argon when they're doing chemical reactions in the container. I think argon is less dense in air, right? It's because argon is unreactive. Just memorize it. I don't even know. Most reactive. Okay. Most reactive. I think it would be the one that does not have a full set of valence electrons. Like, I think it would be sodium. Because it is... okay. We said that the transition metals are from 3. It's not this. I think it's because sodium is in the first group. They have 1 valence electron. So, guys, everything in the first group is an alkali metal. Now, alkali metals are, I think, the most reactive. Ya Rabbi. Most reactive because they only have 1 valence electron and they're like ready to lose it or whatever. Physical property. This is so easy. Silver gray color. Or like blue. Calcium. Oh, okay. Calcium. Calcium is an alkali earth metal, which are usually gray in color, and the chemical property for it is, I think it's not reactive, it's stable. Inert. صح? I think it is. Let me check. Okay. Guys, alkaline. I'm actually sorry because I haven't done this in a long time. This section, but alkaline earth metals are reactive, okay? So the chemical property is reactive. All alkali earth metals are silver grey in color. They're not blue color. They're not radioactive. For 7 elements in the same group on the periodic table have similar chemical properties because of the number of valence electrons. We already said this. Alkaline earth metals, column 2, which is the group. Number of valence electrons is also going to be 2. And it's used in, I think, coins, right? We'll see later. Noble gases, we said that they're in group 18. They have 8 valence electrons. Group 18 is different, by the way. It doesn't have 18 valence electrons. It has only 8. And it's used in, I think, fireworks. Halogens are used in jewelry. I knew everything. Did I pause that? I was searching it up anyways. I knew everything. I just didn't know what they were used for. But memorize this first of all. That the noble gas is 18, 8 light bulbs. Memorize that. That column 18, they all have 8 valence electrons. And you need to memorize that noble gases are used for light bulbs. I thought they were used for fireworks. Anyways, alkali earth metals are an element. Alkali are in group 1. Their atoms have 1 valence electron and lose 1 electron to become stable. They are extremely reactive. صح? Let's check. We were right. Okay. Next one. Alkali earth metals are elements in group 2. Their atoms have 2 valence electrons because they're in group 2 and lose 2 to become stable. صح? Yeah. They are silvery grey. What distinguishes group 13 to 16 from other in the periodic table? I just found out their reverse properties because they don't share the same properties. They like, it's just because they don't share the same properties. That's why they're diverse. Halogens. Okay, let me give you things about halogens, like notes. Okay, these are the notes. Halogens. These are all of the notes for halogens. Group 17, nonmetals. And they're all here anyways. Halogens are found, I think. Yeah, group 17. Now, you guys probably found out something that for the noble gases and for halogens, that since they're group 17, you think there's supposed to be 7 valence electrons. 17, I mean, but they're only 7. And then it's 18 for noble gases in the group, but it's only 8. These can differ, like they can become like this. It's for 17 and 18. I think it's only for 17, 18. Or maybe it's also for more, I'm not sure. Okay, but noble we know that transit meshes from T to 2. Alkali metals from group 1. Alkali earth metals group 2. And noble gases group 13. Group 18. What group of elements form ions with 2 plus charge? Form ion with 2 plus charge? Alkali metals are the first, so they don't form 2 plus. Halogens are group 18. No, group 17. So since they're 17, it's 2. Now they're 15. 8, 7, 7. It's not halogen. Why? Because plus 2, so the valence electron plus 2. Alkali earth metals. It is alkali earth metals because Alkali earth metals have a valence set of valence electrons equal to 2, and since it's like below 4, you want it to be 0, so you're gonna add 2 to even it out. Yeah. Place below the rest of the periodic table. I think it's to make the periodic table easier to read. This doesn't really have an explanation. Let's just check quickly. Yeah. This doesn't make sense. This doesn't make sense because they're all arranged based on their properties, and they're all arranged like groups arranged by the properties and the rows by the energy levels. This is like, just memorize it, but this is the most. It's common sense. Okay. Let's see if we got all correct. For both questions, I forgot to put the. I forgot to answer. I didn't answer for both questions. Let's see if we got all correct. Partially? What did I put? 1817 to 1 coins, light bulbs. Okay. Take a screenshot of this. You can memorize it. Like, you can't really explain why these are used for fireworks. You need to memorize each and their use. Thank you guys so much. I know that this quiz wasn't that good. I hope I helped you out. I did know 1.2 and a bit of 1.3. The rest I was just doing it with you. Like, I was just basically studying with you. But I hope you understood from my notes. If you want to ask any questions, just ask them in the comments. Thank you so much. Inshallah, you do good in your exam. Bye.